All right, ladies and gentlemen, welcome to 2-1. Today we're going to be talking about writing equations, and we're going to basically be translating from algebraic equations to verbal descriptions, right? So that's our objective. Let's go ahead and write that down. Today's objective, learning objective. So I imagine that at this time you are following along in your notes that you should already have, and you're writing in the objective, I will. You can repeat. I will write verbal expressions. Oh, y'all are so good. Expressions from algebraic equations. Now, you may be thinking, I thought we already did this. Well, we did it, but we did it with algebraic expressions, right? What's the difference between an expression and an equation? Yes. The expression does not have an equal sign. Do y'all agree with that? Yes, it does. Okay, so that is true. And so I will write verbal expressions from algebraic equations and vice versa. Y'all know what vice versa means? The other way, right? So we're going to go from algebraic equations into verbal expressions. I like to say we're going from English to algebra, algebra to English, right? All right. Yes, yes. Okay. That sneeze will be on video forever, right? Ladies and gentlemen, here is your vocabulary. By the way, this is my third period class that I'm recording this with. Say hi, third period. Okay. Oh, that will come through. All right, now, ladies and gentlemen, on your vocabulary, our word for today is formula. Can you say formula? Good. It is an equation that states a rule for the relationship between certain quantities. I'm going to actually kind of make this so that it fits in the entire screen. So an equation that states a rule for the relationship between certain quantities. Now, if you're watching the video and you've already finished writing it because you're super fast, of course you can fast forward, yes? Just saying. Hmm. But in real life, hmm. All right. Good. All right. Okay, ladies and gentlemen, let's go ahead and look at example 1A. We want to translate this sentence into an equation. Now, if you look in your previous notes, we did that whole word bank with all those words that have different meanings in algebra. That might be a good one to reference, okay? The only word I don't think we've talked about is. So I'm going to make a little side note here. Okay, I'm going to actually just kind of go over here. What are some words that mean, I'm sorry, what are words that mean, what is in algebra? That would have like less than and greater than, right? Equals, right? Equals is the most common one, right? Can you think of any other words that might mean equal? Same, equal. Anything else? Balanced, okay. Anything else? I think that's a lot, yes? I'll stick in balanced right here, okay? So those are all English words that could possibly mean that we're talking about the algebraic sign for equal, right? Okay, so we're going to translate the sentence into an equation. We have a number b. How do I translate this into algebra? Just write a b. Very good. B, a number b. So in algebra, we just say b, right? All right, next one. We want to divide it by 3. Division sign and 3, right? That looks pretty good. Now, this word is equal to. Equal, very good. And then last but not least, we have 6 less than C. That's right. For those of you who remember, less than is the one where you have to flip, right? Whatever goes in front, whatever's in the front goes to the back. Whatever's in the back goes to the front. C minus 6. So, ladies and gentlemen, this right here is our sentence turned into an equation. Any questions? Yes, ma'am. I love that. Yes. Is this also b divided by 3? Beautiful. Anyone else? Man, it's like we planned this or something. All right, here we go. Okay. So, ladies and gentlemen, let's do it again. Example 1b. Translate this sentence into an equation. Okay, so let's take little bigger chunks now. 15 more than z. Flip. Well, it definitely implies addition. I agree with that. Do we flip? Okay. Let me pose this to you. If I'm adding two things, 3 plus 6, 3 plus 6 is what? 9. And if I flip them, 6 plus 3, I still get 9. Actually, the only phrase that requires us to flip is the phrase less than. So that's a very good note to make in your notes, yes? Knock yourself out, because does it matter? No, what property tells me it doesn't matter? The commutative property of addition. Very good, okay? So, ladies and gentlemen, I'm not going to do more work than I have to. I'm just going to say 15 plus z, right? Times 6 is. How do you think we say that part? All right, equal. What about the times 6? Maybe like that? Yeah? Sound good? Okay. Would it be? Would the parentheses need to be around 15 plus z? 15 more than. When is it that what phrase tells me, hey, we need to use parentheses? Starts with a the. The sum of. When you have phrases like the sum of, you're talking about a phrase that's going to say we have to have a parenthesis, right? Oh, I'm sorry. Oh, like THE, yeah. So, what's another phrase that would imply parentheses? The difference of, the quotient of, the product of. These are all phrases that require parentheses. This one does not, so we're just going to let it be. Absolutely. PEMDAS does say that multiplication comes before addition. That's still okay. Questions? Okay, good. Now let's tackle the other side here. 11 less than y times 2. 2y minus 11 is what the woman says. Is the woman right? She could be. Is there another way to interpret this? All right, yes, sir. Okay, y minus 11 times 2, right? And in that case, I kind of almost would want to put parentheses around that, right? Now, I'm going to tell you, this is where algebra is a little bit more specific than English, yes? Could you kind of see that? Like, if we just address this part, 11 less than y, that would be that part, right? And then times all of that by 2. This is what we would call ambiguous, meaning it could go either way based on the English words that were given, right? So either way, I think is okay, okay? Translate the sentence into equation. So I'm going to say that we could have 2, and I'm going to rewrite it like this. 15 plus z. I'm going to make my z's with a little line through it so you know they're not 2's. And ladies and gentlemen, I would accept either one as an answer. Okay? Questions? Okay. The star more than likely would have, they might even have like, okay, one way they might test it is, here's answer A, here's answer B, C is none of the above, D is all of the above. Okay, that could be an option, right? Maybe not just for star, but a future exam. Yes? Okay. All right, if they were feeling particularly, uh-huh. All right, ladies and gentlemen, 5, 4, 3, 2, and 1. We're back. All right, our first example, we have example, real world example number 2. We want to do jelly beans. A jelly bean manufacturer produces 1,250,000 jelly beans per hour. How many hours does it take to produce 10 million jelly beans? Now, in your notes, we have a grid, right? And we basically divided it into 4 parts. Okay, let me go ahead and raise this up a little bit. Aww. But you know how I know that you could probably already figure out the answer? But we got to look at steps because are all the problems always going to be this baby easy? No, one day we're going to be doing tougher problems, and I want to give you a process to be able to process these problems, okay? Now, what does it say in the very first corner? What do I know? Okay, and you may not know anything, maybe not. All right, what is the next question?
What do I need to know?
What do I need to know? And the third question, your conclusion. And the final, how do I check it? Now, honestly, like for example, if you find yourself with extra time on an exam, and yesterday there were people in here that had extra time, right? How many of you went back and checked your work? Okay. Technically, can't you go back and check it? And you should be in a position where you could get a perfect 100, right? And yet, yes, I had several hundreds. So, yes. Maybe at the end of this recording. Okay, so let's start off with what we know. What do I know? Okay, so what I'm hearing is that we have this jelly beans, I'm going to call them JB, for every, how many hours? 1 hour. That word per means how many hours? 1, okay? So when you see that per hour, you know it's 1 hour, okay? And then the other thing that I know is that everything that I know? Just the rate? Okay. Okay. So we know that they also need to produce 10 million, right? So we want 10 million jelly beans. Okay. Now, what is it that we want to know? How many hours? And you know what I really like about that is that you used a unit. Okay. Because a lot of times we want to say, oh, how long did it take me, right? But that doesn't tell us minutes, hours, years, right? So how many hours will it take? Okay. Yeah. Make sure you think about units all the time. And honestly, think about what the question is, right? Because sometimes you think you're solving it, you're like, yeah. And then what was the question again? Okay. So our conclusion is, any ideas how we go about getting this?
Solving it. It would be the jelly bean.
Oh, wait, one person at a time. Okay. Yes, sir. And then I'll ask you, ma'am. Okay. That should have many hours. Do you have anything to add to that?
I was like, you know how we have the jelly beans on top of the line? You put the 10 million jelly beans on the other side and put other side.
Oh, you could also use a proportion. Do y'all remember that? So, which ends up being the same as what he said. So I'm going to put that because I know people usually love that method, okay? Where they say, oh, okay, I've got this, okay, and I got to put my units. I'm going to put JB here, and I'm going to put hours. When you're using this method, it's really important that you make sure all your units kind of line up. So I've got 1,250,000 jelly beans for 1 hour. And then on the other side, we're going to put that we want 10 million. Is that going to go on the top or the bottom? That's going to go on the... I'm so sorry. Okay, so that's going to be 10 million. And then what we're going to put our unknown in X, and that's in hours, yes? Okay, so then when we do that, we just cross multiply. 1 times 10 million is 10 million, and we are going to divide by, that came out of my mouth weird, right? 10 million, okay. And then we're going to divide by, which is exactly what he was saying, right? So we're going to do that, and I'm going to put in, sorry. Sometimes I don't speak so good. All right, let me see if I can get this. Sometimes it's hard to English. Okay. There we go. Yay. Okay, ladies and gentlemen, so I'm going to take 10 million and I'm dividing it by 1,250,000. Okay? Are y'all ready? Okay. So my zeros all cancel out, right? And I'm left with a simpler problem of divided by 125, right? When I'm looking at this, I can divide it by 5, right? And I can divide this by 5. And when I do that, what is 1,000 divided by 5? 200. Answer is 200. 5 goes into 125. 25 times. Good. I think next week is a good week to start bringing calculators in, yes? 8. Okay, so ladies and gentlemen, 8 what? 8 hours. 8 hours to make 10 million jelly beans, okay? So, of course, we can plug it back in and make sure that it all works. But we're wrapped up with time, so our video is ending. Y'all have a fantastic, look out for part 2.